Hey guys, so I'm super excited because I get the opportunity to teach you about something that I love teaching in math, and that is geometry. Now, if you know anything about geometry, geometry, in third grade at least, is really the study of shapes, basically. So, in order to understand shapes better, you have to first understand what makes up a shape. And shapes are made up of what we call angles and lines. So, in this lesson, in this video, I'm going to teach you about what angles and lines are, basically. And this is actually take two of my lesson. The first time went way too long, so I'm going to try to kind of go through this quickly so that you don't get bored and lose interest. So let's move on. Let's jump right in. So first of all, let's talk about lines. Lines, in terms of math and geometry in third grade, a line is a collection of points going on and on infinitely in both directions. It has no endpoints. So when we draw a line in math, notice we put an arrow on each end, and those arrows simply mean that the lines go on and on forever in both directions. Moving on. Now, line segments and rays. So lines can be divided into parts to make segments and rays. So this is an example of a line segment, and it says a line segment is a part of a line. It has two endpoints and includes all the points between those endpoints. To name a line segment, name the endpoints. All right, so let's take a look. So what's different? This is a line, remember, because notice the line has an arrow on both ends, indicating that it's a line. It goes on and on forever in both directions. But if you pay attention to our definition, a line segment is a part of a line, so it's a piece of a line. Notice what's different about it. We put an endpoint on each end. So basically, imagine this. If we have a pair of scissors, okay, and I go up to this line up here, and let's say I take my scissors and I cut here. Let me use a different color so you can see it better. So let's say I cut it here and here, any two places. And then we took that piece out. That's what we have now. We have a line segment, okay? Now let's talk about array. Array, not array. Don't think array like multiplication and division when we taught you how to draw an array. We're saying two separate words. A ray. It's called ray. Okay. So a ray is a part of a line. Also, it has one endpoint and continues on and on in one direction. A ray is named by its endpoint and one other point on the line. So this is an example of a ray. Notice what looks different about it. We have an endpoint on one end and an arrow on the other end, meaning it goes on and on forever in that direction. It stops here. So again, if we take our scissors and we only cut it in one spot and we took that out, this is where your endpoint would go, and this is your arrow. So this would be an example of array. Okay? All right, moving on. Angles. So when you have two of those rays that have the same endpoint, they form what's called an angle. This endpoint is called the vertex. So if you look, we have a ray here, and then we have another ray here, and they are sharing this endpoint. This is what we call the vertex, okay? So instead of calling these corners in math from now on, third grade geometry, let's not call them corners anymore. Let's call them a vertex. And when you have more than one, there is no such word as vertexes. When you have more than one, we call it vertices. All right. So if you hear me use these words in a later video, you'll know what I'm talking about. All right. So moving on. All right. So it says find the examples of angles in the picture. So these are just pictures of things that we see in everyday life. We have some sun rays here, or some sunlight, some sunbeams shining down. We have what looks like the picture of a corner of like an apartment building with balconies, and we have railroad tracks. If you look very carefully, you'll notice that you can find examples of angles in each picture. There's a ton of them. But what I'm going to do is I'm just going to quickly highlight one example from each picture. So if you look carefully here at this sunbeam, this white sunbeam, notice the shape that it creates as it's shining down on planet Earth. Here's your vertex, and here's a ray, and here's another ray, and they're meeting here, sharing this vertex, and it's creating an angle. All right? On the balcony, the easiest place to see it is if you take the bottom side of the balcony and the other bottom side of the balcony, And where they meet, notice, they form an angle. They form an angle. Let me, boys and girls, I have to pause our video really quick. Oh, I went to the wrong thing. Hold on a second. I gotta pause our video. Okay, sorry about that, guys. I had an unexpected guest. My brother stopped by for something. All right, so where were we? We were talking about how you can find angles in these different pictures. So there's one example. You have a ray here and another ray here, and where they meet, there's your vertex. So that's creating an angle. And then finally, if you look at this railroad tracks, you can see if you traced along each side of the railroad track, you can see that it forms an angle once again. So I challenge you, look around and you're going to notice that there's angles all over the place. All right. All right, let's move on. All right, so with your angles, there's different kinds of angles. And again, I want to move through this fairly quickly because I don't want to make this too long for you. So different types of angles. We're going to focus on these three kinds right here. Don't worry about this one yet in third grade math. So first of all, we have a right angle. A right angle forms a square corner. The measurement of its angle is exactly 90 degrees. So if you notice where this ray meets this ray, here's your vertex, and it forms a perfectly squared corner. So if I were to make a right angle with my hands, it would kind of look like this. If you look around, there's right angles all over the place. The corner of a computer screen, the corner of a piece of paper, the corner of a book, the corner of a door or a doorway, they're all right angles. They form perfectly squared corners. Now, if you take a right angle, okay, and you close your rays together so that there's less space in between the two rays, now you have what's called an acute angle. This is less than a right angle. The measurement of its angle is less than 90 degrees. So you can look at an acute angle as kind of like a smaller angle because there's less space. And here's one way that you can remember what acute means. Since it's a smaller angle, meaning there's less space, you can call it a cute angle, like a cute puppy. Get it? So these are the little guys, okay, that have less space in between the rays. The word acute actually means sharp. If you look it up, the word acute means sharp. And that's another way that you can remember. If you look at the vertex of an acute angle and compare it to the vertex of a right angle, the vertex of an acute angle is sharper looking. And then finally, we have what's called an obtuse angle. It is greater than a right angle. The measurement of its angle is more than 90 degrees. So again, if you look at my hands, if we start with a right angle, a 90-degree angle, but then we take our rays and we open them up more, now there's more space in between the two rays, making it more than 90 degrees. That's what we call an obtuse angle. The word obtuse means dull. If you look at the vertex of an obtuse angle, you'll notice that that point is much duller looking compared to your acute angle vertex and the right angle vertex. So that's just a quick, easy way of remembering the difference between acute, obtuse, and right angles. All right, let's move on. All right, so pairs of lines are given special names based on their relationship to each other. So when we're looking at shapes in our next video, we're going to be focusing on the lines and how those lines look compared to the other lines in the shape and how they meet and where they meet and whatnot. So first, we need to talk about parallel lines. So parallel lines, here's an example here. This line is parallel to this line. They never intersect or cross each other. So the word intersect means to touch or cross each other. So let's watch this quick video. Let's watch this quick video so that you can see some examples of parallel lines in everyday life.
Parallel lines are lines on the same plane that never come together or intersect. Parallel lines can be seen on the edges of straight roads and in the traffic traveling on them, and in train tracks. Highways are divided into lanes by parallel lines to help guide the traffic. Swimming pools also have parallel lane dividers to help guide the swimmers. Even if we could stretch out the lines forever, they would never intersect. Parallel lines can also be found in smaller structures, like this porch, as well as this fence. Lots of musical instruments also have parallel or nearly parallel lines. Look at these piano strings. Cello strings are very nearly parallel too, as are the strings on a guitar.
All right, guys. So hopefully you have a better understanding of what parallel lines are. One way that you can remember what parallel means is if you look at the word parallel. Let me choose a different color here. If you look at the word parallel, you can see right in the middle of the word there's two lowercase l's. And when you look at those two lowercase l's, you'll notice that they look like two parallel lines because they are two lines that are parallel. Those two lowercase l's will never touch each other because they're always the same distance apart from the top to the bottom. So in the word parallel, you see an example of parallel lines. That's one way to remember. Let's talk about the word intersecting in terms of intersecting lines. Intersecting lines cross through each other at one point. Now, it's important to understand this. Intersecting lines don't always have to cross through each other. Where you have a line meeting with another line, we also call that intersecting. So basically, when two lines touch, whether they touch and stop or touch and cross through each other, we call those intersecting lines. Let's take a look at this video, and you'll see some other examples.
Intersecting lines cross at a single point. Train tracks run parallel, but they intersect when they cross another set of tracks in a rail yard. Note how the intersecting tracks are like intersecting lines. The panes on this window form a series of intersecting lines. Just like parts of this bridge, take a look. Where lines intersect, angles are formed. The angles on the bridge are less than 90 degrees. They're called acute angles. Look at all the acute angles just on the near side of this bridge. Angles greater than 90 degrees are obtuse angles. There are three types of angles: acute, obtuse, and right angles. The top section of this building is in the shape of a trapezoid. It has four angles inside the shape, where edges of the building come together. Two of these angles are acute, and two of them are obtuse. These sides of the trapezoid are parallel, so if extended endlessly, they would not intersect, but here, they stop.
All right, so not only did that show you some examples of intersecting lines, but it also got into our conversation about the three different kinds of angles that we learned about, as well as at the end, it shows you an example of how on a trapezoid, the top line or the top side of the trapezoid is parallel to the bottom side. Very good. All right, so let's take a look at the other kind of lines that we're going to be talking about, and that is perpendicular lines. So here's a picture. Now notice these do intersect just like these lines here, but there is a big difference between intersecting lines, regular intersecting lines, and perpendicular lines. So perpendicular lines are intersecting lines that cross through each at one point or through each other at one point. The lines form right angles. So that's the difference. Where these guys intersect, these angles that they form, that angle is an obtuse angle, and on the opposite side, that's an obtuse angle. Then if you look to the left, there's an acute angle here, and to the right, there's another acute angle. So where they intersect, they don't form right angles. So that's why we just call them intersecting lines. However, where these lines intersect, you'll notice that they form right angles, those perfectly squared corners. Okay, you can see a right angle here. You can see another right angle here. You can see another right angle here and another right angle here. So there's four right angles formed around that vertex where they intersect. All right, let's take a look at this video so that you can see examples of perpendicular lines in everyday life.
Perpendicular lines form equal angles all the way around. On this chessboard, we can see where all the lines meet. They form square 90-degree angles. Many tiled floors also have perpendicular lines, forming right angles where they intersect. This traffic sign has a 90-degree angle. And this monument has many perpendicular lines. Let's highlight where the lines meet to form right angles. There are 8 right angles.
All right, hopefully you understand what perpendicular lines are now. We're almost done, boys and girls. All right, so finally, now that we've learned about some of these terms and what these different lines are and angles are, let's take a look at two common shapes where you can see some of these examples inside the shape. So here's a square, for instance, and it's pointing out that these two lines, notice it's pointing to the top side and the bottom side is saying these two lines are parallel. So there you go. You can see it a little easier now. So the top and the bottom are parallel. And not only that, if you look hard enough, you'll notice that the left side and the right side are also parallel to each other. Meaning, again, they are the same distance apart. They will never touch, even if they go on and on forever in both directions. All right. Now it's pointing to this side, so the right side and the bottom side here. And it's saying that these two lines are perpendicular because if you click here, you'll notice where they meet. Right there, that vertex, you have a right angle formed, a perfectly squared corner. So not only do you see a right angle here, but you can see a right angle here, meaning this side and this side is perpendicular. A right angle here, so the top and the left side is perpendicular. And another right angle here, so the left and the bottom side are also perpendicular. Jump over to this triangle over here. It says these two lines are intersecting, so this side here is intersecting this side here because they touch right here. They meet and form that vertex, that angle. So then you can see it there, how they intersect. And then down at the bottom, it's pointing to the bottom side and the right side here. And it's saying that these two sides are perpendicular because where they intersect, where they meet, you can see it's forming a right angle. These are not perpendicular up here because this angle is an acute angle. But these ones, where they intersect here, the bottom and the right side, these two sides are perpendicular because they form that right angle. So boys and girls, in our next lesson, now that you understand what lines are and the different kinds of angles, we can use that knowledge to help us classify and categorize and identify different shapes now. So that's what we'll be looking at in the next video. All right.